Well, hello everyone, and welcome to another tutorial. What you're currently seeing on the screen is a little something I put together to try out utility functions applied to artificial intelligence, sort of. So what you're seeing here is basically a grid, and there's a couple. You can think about this like an RPG kind of game, where you have these castles in red, and it says castle. And then you have all these other dots, which are basically guards that are, according to some rules, occupying several positions on the grid itself, on the map, so to speak. So you can see that some guards have different colors, and this is basically the type of guards they are, and they take into consideration different factors for the positioning on the map. And in order to do this, I'm using a technique usually called utility AI, which basically uses utility functions to provide value, so the guards can decide which position has more value for them on the map, and so they use that position as the place to be. And so this is a little thing I did in JavaScript, and I'm basically going to explain now how we can reach this point, basically. So the first thing we need to do is I'm going to do this in JavaScript, and I'm going to be using JavaScript modules, which means that CORS or cross-origin request something will not allow me to run to import modules inside if I'm serving with a file ://. So we're going to start by installing a little HTTP server globally using npm. If you don't have npm or node, you can just install it. It shouldn't be too hard. Just Google install node on Windows or whatever operating system you have. And we're basically going to install, after having node installed, we need to install the HTTP server. I think I already have it installed on my machine, but anyways. So then we go to the folder where we want to run the HTTP server, and we just run HTTP server. And I actually want to run this on the tutorial folder, because that's what I'm going to be working on. And HTTP server. And this starts a small web server that we can then access on the browser. If I can make this work, tutorial UI. Oh, sorry. I want to run it from here. So this is the starting point. So we have one castle, one guard, and this guard is basically predefined. Its position is currently predefined to a certain place. And I already have some boilerplate code laying around. I have like a grid module that basically defines all the tiles on the map. And I have a couple of utilities to turn a certain grid position into a screen position. And I have the ability to draw using the canvas context to draw this grid or this rectangle for each of the grid positions. So this is the grid. Then we have simple stuff like utils contains like a simple vector 2D class to basically to easily represent basically X and Y on the map, and whatever else kind of pair of values that we want to store. And then I have a simple circle, which I'm using to draw the castles and also the guards with different parameters, of course. I have like a small function to truncate decimals into 2 decimal or whatever number of decimals you want. And yeah, this is just some utils. Then I have the guard class, which basically extends from a circle and has a bit more information like his number and his position on the grid, and then has a method to update his position. Basically you pass it X and Y and you say where you want it to be, and it will basically start drawing it in that position. The castle is pretty much the same. It extends a circle and has a position and draws itself and draws the castle text as well. Then I have this special module that is currently empty, which is going to be the considerations for the utility functions. And basically the HTML that you see is basically just HTML with a canvas, and basically runs this on this function on this module UI, and runs this run function, which does some setup in the beginning, creates the guards, in this case just one guard, and updates its position, creates the castle as well, and calls animate, basically gets into a loop animating the canvas basically. And while it's animating, it basically draws the grid, draws the castles, and draws the guards. And we only have one now of each, but we will soon have more. So just a little intro in how or why we would want to use some kind of AI, because you could argue that, okay, I want this, let's say I have a rule that I want this guard to be the guard of this castle, and I want this guard to be close to the castle. That's fine. You could just, get the castle's position and then put the guard inside the castle or around the castle, or do a random around the position of the castle that you want to have, and that would be fine. But what happens if later you decide to have two guards, and you don't want these two guards to occupy the same position, or you want the probability to be really low? Then you would have to check each of the positions, check each of the guards, and then later you add yet another consideration to this predicament that we have, where you have another castle, and you want these guards to be distributed between the castles. They need to be close to both castles. So you can see that you have to start writing a lot of rules for this, and there's an easier way to do this, basically using utility functions, where you basically assign a float value to each one of the positions on the grid, and you use considerations to do all of these calculations in a modular way. So each of the considerations just returns a value from, let's say, 0 to 1. 0 being I don't really like this position, considering this consideration, and 1 being I really like this position. Then you do an average of all the considerations that you're taking, and in the end you have like a degree of importance or utility for each of the grids, each of the grids positions, and then the guard can just pick the best one, or pick a random between a couple of them. So you can later decide what you want to do with this, but the most important thing is that you have a ranked importance of the grid's positions for each of the guards. So let's see how we start to do this. First thing I'm going to do is I'm going to disable here on network, I'm going to disable cache, just so as I write code, the browser always loads up the most recent code, basically. And let's start with a really simple consideration. Let's write the distance to the castle consideration. So maybe we start with a consideration itself. Let's make a base class for the considerations. I'm just going to copy paste this one because it's super simple. It's basically a class that we pass in. This is going to be for later, so I might not just pass this just yet. Let's just have the context having being the grid and the guard. So basically, this consideration knows about the guard that is being considered for a certain position, and also about the grid, so we can take some decisions regarding the grid. And basically it has a method called consider, and this method will return a value from 0 to 1 depending on how it likes the position we are considering. And I believe I need to pass in the position of the grid that I'm considering as well. I probably made a mistake before. And so let's see the castle. Let's create a consideration for the castle distance, and this could be like pretty generic. You could later basically just say that this is a distance consideration, and it just passes in a couple of objects, and then considers whether or not it likes the position based on the distance between them. In this case, we're going to be a bit more specific, and since we're making a kind of a specific game, and let's just do castle distance consideration. Let's extend from consideration, and let's put in well, let's start with the consider function that we want to consider a position for here, and let's see, we will need also a constructor where we want to pass in the guards and the grids, and let's pass in the castle as well, because we need to consider the distance to the castle. So let's call super guard grids, and let's store in a context. So I forgot to say that the context is like the shared knowledge of for all the considerations. So it's like their knowledge of the world that they can use to make the calculations they need. I'm sorry. So let's add in the, if I can type, let's add in the castle position to our context. So it's going to be castle.position, and now we'll calculate the maximum distance let's calculate the maximum distance to this castle for all the grid tiles, basically, and that's kind of easy. Let's just do max distance equals 0, starts at 0, then we do for const tile of grid.tiles. We basically go through all the tiles in the grid, and we store a const distance equals tile.distance2. This is basically a simple method in the vector2d class to calculate the distance between two vectors. And let's use this .castle position. So we're calculating the distance between the castle and each of the tiles, and if the distance is greater than the max distance, we just set the max distance to the distance. So we're trying to figure out what's the furthest away we can be from this castle in terms of the tiles in the world. And let's store the castle max distance as being the max distance that we found, right? So now how do we consider this, or how do we calculate for a particular grid tile? How do we say which value is it, or how important is it that to be close to the castle? So we basically do that position dot distance to the castle position, context dot castle position, and we divide that by this dot context dot castle max position. That gives us a linear how do I say, a linear ratio for each of the grid places in terms of distance to this castle. But I don't want this, because this will give me 0. Okay, let's see what this gives us before we start. I need to return here. This is JavaScript. So let's see. Let's try to add this into our code. So I'm going to the guards, to the guard.js, and I'm going to, well, first off, this guard needs to store some. It has to have like let's call the utility values for each of the grid positions for itself. So it's how it's going to decide what the best position for it to be is. So let's create a position utility, and let's initialize this as an array, basically a two-dimensional array. And I know I'm passing in values that I don't have yet, but I will, I promise. So gridx count dot fill dot map, and I want to map this to an anonymous function that is also another array of grids y count, and I want to fill this one as 0 as well. So we basically create a two-dimensional array filled with zeros. of size grid x count, and let's put this in here as the constructor for the guard, and grid y count, right? Okay, cool. That's a start. Let's see how we're constructing our guard. I think I was already passing the grid. Yeah, I was already passing these values in. This is basically the number of tiles that we have on the X and on the Y. No big deal. So with this position utility, we can, let's see, we can start updating this function here. So instead of hard coding this guy to this position, which I'll probably do later anyways, what I want to do here is something more along the lines of okay, let's see. Let's create a variable called utility values and initialize it as an empty array. And let's go through all of the values in our position utility. X less than this dot position utility dot length x plus plus. Let's do the same for y. And this, I want this to be like the first position, or x, the x position. And for each of these, let's say the position is a new vector 2D of x and y. And let's think this ahead. We want to have multiple considerations as well, not just one potentially for each guard. So I will already create an utility value variable starting at 0, and let's iterate between a consideration C of considerations, which is something I'm going to pass into this function. And I might just put it already here. Let's okay, I don't think I need these x and y now because I was only using it to draw. Yeah, so let's put considerations and then the grid. I'm not sure we're going to use the grid, but let's leave it for now. So we run through all the considerations and we basically add in the utility value that we gather from this consideration. So let's just call consider this position that we just defined. And after I'm done with this, I will just do this dot position utility x and y. It's going to be equal to the utility value divided by the number of considerations. And this is the way we average considerations. Dot length. This is the way we average the value of each of the considerations to come up to a final value or utility value for that particular position on the map. And I'm actually only going to use this position utility for display. I actually want to create another one called utility values. I already did, and I'm going to use that one for the calculations because I don't want to just pick the best position that I get. I want to do like a reasonable random of positions just so it doesn't get, you know, just fixed. It will always pick the same position based on the value. This way you have like 5 or 10 values that are reasonable for the guard to go into, and you don't get, you know, always the same one. So let's push into the utility values a new dictionary with the position and also the value that we calculated, the utility value. This is going to be this dot position. Well, I could just do the same utility values divided by consideration length, but I'm gonna do this because it's already calculated and it's one less thing to calculate. And after we're done with this big for, we can sort the utility values and randomize between the top, I don't know, 5 values or something like that. We can make it configurable later, but for now let's just go with 5. Sort and function u1, u2, so utility value 1, utility value 2. And what I want to do here is return u2.value minus u1.value. This will basically sort our utility values. And now I just want to pick utility values dot slice. I want to slice this with 0 and say 5. And now I want to pick a random between these 5, basically. So const picked utility equals utility values of math.random times I believe 4 to get between 0 and 4, and since I have 5 values that would be okay. And having done this, I can do this dot position equals picked utility to that position, and I just need to update the. No, I don't need to do anything because I'm drawing using the. Oh, I'm drawing using the screen position. So I still need to do this conversion of the position into the screen position. This is mostly just for drawing. It has nothing to do with the thing that we're discussing. It's just a way to draw this thing. This will just convert the position in tiles to a position on the screen. Fine, so we still use the grid, which is good. Now we can go back to UI.js. We don't pass in this position anymore. We actually want to pass a bunch of considerations. And what considerations are they going to be? They are going to be, let's do const considerations equals an array, and let's make a new castle distance consideration where we pass in the guard. So we need to do this for each of the guards, which means I'm going to put this inside the loop of the guard. And the guard is G, and the grid is grids, and the castle, let's just do castles of 0 for now. Just for simplicity, let's do it like this. And then we'll update the position of the considerations, and let's see if it works. Probably not, but it never works the first time. Okay, cannot read property position of undefined on the guard update position, guard 39. Guard 39 here doesn't know what picked utility. Did I make a mistake here? Oh, I missed something. Math.round of this. I might have more mistakes, but let's see. No, I don't. So as I was saying, I am now getting the most further 5 positions that I can get from this castle. And I want precisely the opposite. I want to be close to this castle. So what I'm going to do now is basically go to the castle position considerations, return 1 minus this value, which is basically inverse the probability. And now if I refresh, I get a close position to the castle. And that's cool, right? So, like I said in the beginning, you could do this in a much simpler way, but now what happens if we add another castle? Well, if we add another castle, it's just super easy to adapt this because the castle distance is modular. We can just do, let's create another castle. Let me see. Let me just see where I can put this castle. I'm just going to copy paste from what I already have here, which is it just simplifies things. Let's see. Let's put a castle here. And now let's also, since I want to pass in all the considerations for all the castles, let's just create here, let's create a castles considerations, because I already know that I'm going to add more types of considerations later. So I'm I'm basically going to add in all the castle considerations to basically all the castles that I have, and I just want to pass in the guards, the grid, and the castle C inside of castles, and then let's just pass in the castle considerations to our guard. So now we should have two castles, and this guy will pick a position between all of the castles. See, the cool thing is, since we're averaging the considerations, I just can add more and more castles, and it will always do the average of proximity between all the castles. And this is just one of the rules. So let's see how we can visualize this thing to see what's being calculated for each of the grids tiles. I'm just going to copy paste some code here, and let's see on animate. I'm basically just iterating the position utility for our only guard that we have, and I'm going to draw on top of that position no, I don't actually need this. On top of that position, I'm going to add what the position utility is for that particular grid tile. So as you can see, maybe it's a bit hard to read, but you can kind of see that the further we go from the castles, the lower the value is. And towards the middle here is actually where we have the strongest values. And that's why it's going in there. Because if I just, disable one of the castles, for instance, and I refresh, you can see that it's going to be 1 exactly on top of the castle. And it's going to tend towards 0 as I go to the corners or more far away from the castle. So, and this is the basis for the utility functions and for utility UI, or AI, sorry. You basically calculate a bunch of floating point numbers between, it can be 0 to 1, but it doesn't matter, as long as it's kind of normalized. And even then you can probably get away, depending on your particular application, you can have different kind of value scales for the considerations depending on what they are. But the idea is that you have a bunch of floating numbers that decide how important it is, how something, or how an action, or our position in this case, how important it is versus all the other ones, as opposed to having a bunch of predicates and then actions. So basically a bunch of rules or fixed rules. And this gives you a bit more flexibility in terms of the reasonable values that you can get, and then the randomness, but still getting kind of good behavior in terms of artificial intelligence. Let's add in our castle, our other castle again, and let's add in another guard. Let's get another guard in there. Oh, sorry, I don't need to do this. Actually, I just need to put 2 here. So now we have 2 guards, and this happens. So what happens is that guard number 1 and guard number 2 are basically reaching the same conclusion, that that particular tile is very interesting to them, and they both occupy the same position. So another thing we could do, and this is going to happen a few times. It's random between 0 and 5, so there's kind of a 1 in 5 chance that it's going to happen, but it will happen. And this is a bit annoying. So one thing we could do is like create a consideration that takes into account the distance to other guards. So I'm just going to add more guards just so you see that this becomes much more apparent. And let's add in, say, I don't know, 20 guards. What happens here? You see that you only have like 5 slots max occupied, because these are the 5 top values that we decided, right? We could just solve it by saying, yeah, okay, then the consideration can get, instead of 5, we could use, I don't know, where's the consideration? On the guard. Instead of 5 results, we could have like 15, and if we do this, then we get a better distribution. But there's another way to do this. We could just still give the same 5 top results, but we could just have another consideration to the mix that would solve this for us. So let's create a consideration that basically tells a guard not to be close to another guard. And let's call this away from other guards consideration. An extends consideration, of course. And let's say we add in our construct. I'm just going to copy paste to speed this up a little bit. Basically, we're going to accept the guard that we're considering for, all of the guards that we want, and then we just put in our context all the other guards by filtering our guard from the other guards, or from all guards, and we just get all the other ones. And now just create the consider position function, and this is going to be a tricky one. I'm just going to copy paste it and instead of writing to make it a bit faster, but I'll explain it. So one optimization I'm doing here is if there are no other guards, I basically return 0. Okay, I could return 1. I think it wouldn't really affect anything. It would just mean that this consideration returns a fixed value for all of the positions that it's considering, which means in the end that doesn't affect the overall order of all the considerations averages. So I basically start by calculating the max distance to any guard from this position. What's the farthest guard that I have from this position? And then I basically divide all the distances that I have to the other guards by this max distance, and I get an average. And then I basically use that average divided by the guard's length, and I basically get like in the end I get an average distance to all of the other guards, and this value will make me like when we had the castle the first time without negating this value here, we would get away from the castle. This basically is separating me from the average distance to a guard, so to speak. There's a couple of optimizations here to make sure we don't get strange stuff like not a number and we get 0 basically, but that's what this does. So now let's add in this consideration. And let's see, let me do this in a way that is easy to extend. So I have the castle considerations. I'm going to update this guard's position with an array of considerations concatenated with the castle considerations, and then I pass in the grid. So this way I can add individual considerations here, and I'm sure that I always pass in the castle considerations as well. So this means I can now do new away from other guards consideration that takes in the guards, all guards. Well, all guards is basically guards in this case. You know what? I'm going to extract this to a variable because I already know I want to do something else later. So I'm going to put this here. All guards equals guards for now. And I pass in all guards. Oh, if I can type. And I pass in the grid. Okay. So I'm updating the position with our castle considerations and away from other guards consideration. Let's see if this does anything. It does not, because I made a mistake somewhere, and I think the mistake was unexpected token in consideration 64. I probably made a mistake here. Yeah. Next bracket. Cannot read property x of undefined vector to distance on the considerations 42. Guard distance, position distance 2, g dot target position. Yes, okay. I had this also already set up for the animations part, which I'm not gonna do right now, and that's why it's not working. Okay, as you can see, even though we only have 5 possible results, it's already a lot more diverse, simply because we are averaging all the considerations. We're also taking into account the distance to other guards, and this makes the guards distribute themselves a lot more than just filling up those 5 possible positions. And let's add a few more castles as well in here, just we can see them spreading apart a little bit more. I'm just going to copy the other ones I have from my example, and if we update this, we get a more cleaner distribution. As you can see, they try to stay as close as possible to all the castles. Some of them they cannot, but it's kind of averaging around the middle. Cool. So we now have a modular way to consider where we want to be, and we can just add more considerations. Let's say we wanted the consideration. But you know what? We don't even need more considerations to get other behaviors. So let's say we want another type of guards that are basically patrol guards. They don't really care about the castles, but they do care about staying away from other guards. There's a super easy way to do this now, because we can just do we can just create some, let's say, where we want to do this. We have the guards here. We have our castles. Let's create patrol guards here. And this is an array. By the way, my JavaScript is far from the best. I don't do this in my day-to-day work usually, and structuring JavaScript modules is a pain in the ass, and I really kind of hate it. But it's the language that allows me to do this tutorial faster, and that's what I went with. So okay, we also need to draw them like we're drawing the guards here. Let's also draw, I can't duplicate. Okay, let's also draw the patrol guards, and let's instantiate them as well. By the way, on the updating, I want to kind of, let's see, I have 20 guards. I'm going to add like, I don't know how many, 15 patrol guards, I guess. Let's add 15 patrol guards. Let's make their color, I don't know, blue, to stick to the plan. And yeah, that sounds good. And now we need to kind of update their positions. So I'm just going to copy paste this here. So we're updating the position of the guards. Let's update the position of the, oh, not here, sorry. Wait. No. Of the, you know what? I'm just going to copy this and make these patrol guards. I don't need this to be here. Actually, I kind of made a mistake. I also don't need this to be here. This can be outside of the guards loop, all the castle considerations, and also the all guards can be outside of this. Okay, this one needs to be, because this one is dependent on the guard itself, but this can be out, the all guards. So all guards is going to be all guards.concat with patrol guards, just adding them to the already existing array. That's why I extracted that before. And the guards, they take into account the castle considerations. Now I have this duplicate. And they do their update position. The patrol guards, they don't really care about the castles, so the only consideration they're going to have is like staying away from all the other guards, right? And yeah, let's give that a try. Yeah, exactly. So what happens here is that the patrol guards are just, you know, trying to stay away from each other and from the, also from the guards that are in the middle. And this kind of happens spontaneously. So they become kind of outer skirts patrol guards just by not adding the castle, the distance to castle consideration, but just adding the away from castle, away from other guards consideration. We have another one. We can have like let's add in some elite guards that just stay close to the first castle. Let's say this castle is the citadel, and let's add in some citadel guards. Hopefully I'll do this faster now. Let's just duplicate this, and these are citadel guards. Let's create the citadel guards. Let's make them, I don't know, 5, just a couple of them. And let's make their color, I don't know. Let's see what happens. Citadel guards, and concat this with citadel guards. So we have all the guards, and these guys are going to be exactly like the patrol guards, but with 1 extra castle distance consideration. And it's going to consider castles of 0. So they are only considering the position to the first castle. See? They just orbit around the first castle that we defined, which is this one. And we didn't do anything else. We just, you know, added these modular considerations that we can create like a gazillion more for anything other than we want. Like, for instance, now we have 4 citadel guards here. This means that one of them is occupying another one's space. Now this can happen. We have the away from other guards consideration, and we can increase the value of that particular consideration if we wanted to. But there's yet another way to do this. We could just create a consideration that really explicitly says that one guard cannot occupy another one's space. And it's super easy. We just create a new one here. We just export class, let's say personal space consideration. Okay, if I can type. Personal space consideration, extends consideration. And let's put in this as well, which is going to be exactly the same that we have for the away from other guards. And let's do the consider position. And I guess I want this to be true as well. So if there are no other guards, I just return 0. It's just an optimization. And other than that, it's super simple. I just do for const g guards of this dot context dot other guards. So I iterate other guards. And if g dot position dot x equals position dot x and g dot position dot y equals position dot y. So if there's already a guard in that position, I return 0. Otherwise, I return 1. And now I just add this personal consideration to, let's say, the Citadel guards to try it out. Oh, my bad. Let me just do this. G all guards, G comma all guards, and grid. And all of a sudden, I have an error. Haha. Personal space consideration. Okay, I'm probably not importing this from the module. I'm not even sure I did an export. I did an export. Oh, I got a major bug here. I think I moved this. Yeah, moved this line. And yeah, so as you can see, now the Citadel guards cannot occupy its shadow space. They're always 5. Always. They just cannot do it. And now, since this is super reusable, I can just push this personal space consideration into the, I don't know, all of them, I guess. So, and I can just have no one occupying each other's space anymore, just by adding a line of code. And I think this is really powerful. This is a really powerful concept, because now you could, like, say you are writing this game and you want to have like some civilian villages, or you want to have some enemies, and you want to decide if you move towards the enemy or away from the enemy. You can have a health consideration for the guard, so it will move towards the enemy if it has full health, but if its health starts dropping because it gets hit, it starts to run away towards the castles probably. Or, you know, you can have all these sorts of things that you can do in a really modular way. And I think this is really powerful. And this is basically what I wanted to show you. I will have all the code available as a link on the video. And yeah, hopefully this inspires you to use this kind of stuff for your games and for your AI, basically. Just some final thoughts, I guess. So the utility AI is really cool, but it's not everything there is, and it's certainly not the best for all situations. There are certainly situations where you want your AI to do something no matter what, or basically according to a really strict rule. That could happen, and since this is fuzzy by nature, it wouldn't be like the best probable solution. You could fake it. You could just say, okay, I really want this guy to do this, so I'm going to just push a utility value that is really high, that is kind of going to shadow all of considerations, and I will make sure that it happens. But that's not kind of the most gracious way of doing it. So there are situations where you probably want to use something like behavior trees based on rules, and you can even mix and match. Like in a particular situation, it's going to do like a rule-based approach. But if something happens that makes sense for a particular situation, then I can use another kind of reasoner that is based on utility AI that gives you like a random reasonable value or action to take in that situation. So your mileage may vary, but I think this is really powerful to get to know, and especially because it allows you to do things in a modular way. You can, you know, just plug in new rules, and if you make them generic enough, you can even basically port them between projects, which is really cool. You can have like an AI engine, an AI kind of module that you share across all your projects, and it has these generic considerations. And then for each of the projects, you can create more specific ones for specific cases. Yeah, so I think it's a really cool concept, and it's an old concept, and it's really an interesting one. So yeah, I hope you liked it. I'm sorry for the time it took to explain all this. I could probably explain it in a nutshell in 5 minutes. But yeah, I think I wanted to, more than anything, I wanted to share like a practical example that I couldn't find a lot of them out there, and just have something more practical for people to look at. So yeah, if you liked it, consider subscribing to my channel and seeing my other videos. I have some interesting tutorials as well on Unreal Engine. And yeah, so have fun. Thanks, guys.